We continue Unit 16 with growth and decay. We are going to begin by constructing a table of values and graph. In your calculator, go to y equals, plug 3 times 1/2 to the x power n to your calculator. Make sure the 1/2 is in parentheses. Use the little caret key to raise your power of x. And look at your graph. My graph did not show up properly, so I'm going to hit zoom 6 to fit that in there. Now I need to graph this, so let's go to our table of values and let's figure out what these values are. Now I can use any values, but we want to keep it simple, so numbers around 0. So we get -3 is equal to 24, -2 is 12, -1 is 6, 0 is 3, 1 is 1.5, 2 is 0.75, and 3 is 0.375. Now we need to graph these. Obviously there are not 10 units on the x and on the y from the origin. We're going to have to fix our scales. This is the x-axis, this is the y-axis. Since there's 10 here and I am using 1 digits for my x, I'm going to leave my x's as 1s. But my y's get really big really quick, and 24 is my biggest number. I am going to use 2's. Now let's graph. If I go out -3, I will be moving up 24 units. So somewhere up here in this region. -2, I will be going out 12 units. -1, 6 units. 0 up 3. Out 1, up 1.5. 2.75. And these numbers are getting very small. And from the calculator a while ago, we only saw this much of the graph. Now graph this. And this graph will continue going, but it will never touch y is equal to 0. It will never cross this line. This is my asymptote. Remember, asymptote is our boundary line. We can also get an idea of how our boundary line looks by looking at our graph again. Going back to the calculator, it looks like it's going towards this line, but you do not see the graph down below. If I go to second table, as x increases, it's getting closer to what looks like 0. So when I go to the table and I look as x increases, these numbers are getting smaller. The y values are getting closer to 0. It never crosses y equals 0. So this is our boundary line. I've graphed it, and as you notice, as x increases, y is decreasing. Y is getting smaller. Let's look at another graph. And now let's plug in this equation and hit graph. This graph is rising in the other direction. Let's find some points and plot this. Now graphing these points, I can use the scale for the x and y axis to be 1. Out -3, up 0.59, -2, 0.89, -1, 1.3, 0 up 2, out 1 to the right and up 3, out 2 up 4.5, and out 3, 6.75. This is our graph. It's getting closer and closer to y equals 0 again, but it does not cross, and y equals 0 is our asymptote. In this graph, as x increases, as we go out further on the x-axis, The y values are also increasing. So as x increases, y increases. In the exponential function, y equals c times a to the x, and this is multiplied. If a is less than 1, in other words, 1/2, 0.3, less than 1, the value of y decreases as the value of x increases. And the graph represents a model of exponential decay. So this right here is a representation of exponential decay. If we start reading our graph from left to right, and this graph starting at this point is going down. It decreases. If a is greater than 1, the value of y increases as the value of x increases. And the graph represents a model of exponential growth. This graph right here, the x increases as the y increases. This is an example of exponential growth. Now we need to classify each of the following exponential models as either growth or decay. Remember, the C has nothing to do with whether this is a growth or decay. We are looking at what A is. The C in this case is understood to be 1. My A is 5. 5 is greater than 1, so this is an exponential growth. Example B. My C, again, is understood to be 1. A is 0.4. 0.4 is less than 1. So this is an example of exponential decay. It will have a graph that goes down, whereas A would have a graph that would be rising. Example C. My C is 8. A is 0.25. 0.25 is less than 1. This is an example of exponential decay. It will have a graph that goes down. Example D. My C is 4. A is 2.5. 2.5 is greater than 1. So this would be an example of exponential growth. Graph that would go up. Don't be tricked. Sometimes you have problems that have fractions, and you need to make sure that the A is indeed less than or greater than 1. In this case, my A is 3/2, and since 3/2 is 1.5, it is greater than 1. So this is a growth. So be very careful with fractions. This concludes the growth and decay part of Unit 16.